Hi everyone. This is I think day 6 and wait, what just happened? I think screen copy it gave up or something. It's gonna open it again. Right, so this is day 6 and what am I doing exactly? Um, I just completed the RNN thing that I was talking about yesterday. Uh, right, and yesterday I thought it was like day 4 but it was day 5. So now it's day 6. Fine. So what am I doing right now? So this is basically the code that I used for that neural network thing that I did a long time ago at this point. But I've made some changes to that, and now it has a new class called RNN, which is recurrent neural network. And so now I can implement a recurrent neural network using this library, sort of. I still don't know what's the correct word for whatever I've made, but I'm just gonna call it a library at this point. Um, yeah, so this is like how the neural network, actually, you know what, I'm just gonna run it because that's just better. So this is the whole neural network, how it like looks like. uh, yeah, so you have 3 layers over here. So let me just like explain what a layer basically is. So what is a neural, like what is an RNN used for? Say you have some word, and using something like word to vector you got some embedding for that word, you vectorized it basically. And so let's just say that that initial word is x0. So x0 is a vector which represents the word. Now what you do is that you like, okay, how do I say this? Let's say you don't have like just one word but like multiple such words. So you have like x0 and then x1 and x2 for example. It's like 3 words, and thus you have a sentence. Now what you want to do is, given a sentence, figure out whether or not you know the sentence is like in it's a positive statement or it's a negative statement. Like for example, the sentence "I hate you," that would be a negative sentence, while "I love you" would be a positive sentiment sentence. Similarly, like "I have fun" or "I had fun" would be a positive statement, while um, "I had pain" or "I felt pain," that would be a negative sentence. So um, you notice that what was I going to say again? So you notice like sometimes, so okay, so this is like a very simplified task. You just have to figure out whether it's positive or negative. So that's not what an RNN is actually used for, because that would just be something that you do using a normal neural network, right? You just concatenate these vectors into a single x vector and then use that to predict the outcome, which is positive or negative. But RNN is slightly different. um, so I don't know, say you want to, how do I say this, I don't even know where to like begin. But say you want to do a many to many sort of like a function, like you take in multiple such vectors, and then you output um, like multiple vectors as well, uh, based on these vectors, then that's where an RNN is used. I don't like have a good example right now. um, let's just think. uh, yeah, it's kind of hard, isn't it? Okay, so let's just say like you want to figure out what the next word is in a sentence, right? So like these are the first 3 words in a sentence, and you have a missing word. So your machine is playing this fill in the blank game, and it wants to like figure out what the next word is going to be. What are the things that you will instantly look at to figure out what the next word is going to be? So for example, if you didn't know what x0 and x1 is, but you did know that this thing is a verb, then you would expect that this would not be a verb, right? Sort of like that, because 2 verbs in a row, it's not like, okay, sometimes that is going to happen. But okay, so let's just say that this was the word not. then you know that this will never be not, right? Like this being not is just improbable. So how do you figure out what this thing is going to be? Like what are the things that play into that prediction? So it's obvious that the most important thing that you look for is like what this word is, right? So the grammar and syntax and all that, and even just like the semantics, in fact, because it could be that x0 and x1 are in themselves contained, they are not like linking to whatever this pair is doing, and so in that case just x2 is what you use to figure out the next thing, right? But what if like it's x1 x2 and then they combine, make a phrase, and then you use that to figure out the next word? So there's like a lot of complications with that, right? So what um, what RNN does is like, it suppose you have a sentence x0 x1 so on till like xn minus 1, and then you want to figure out what xn is, right? So you don't know what that is. What an RNN does is that, okay, it takes x0, right? Okay, so first it takes some sort of a hidden state, uh, right? So like say that initially you just don't know anything, right? So you just like randomly assign your machine some state, so we'll just call it h naught vector. So it takes x0 and then it outputs two things. First it outputs a y0 vector, which, okay, so once again I think I kind of got a bad example, but like whatever. So this is like sort of optional, but I'm gonna include it there. So it can output a y0 vector. It's up to you whether or not you want to use it. Okay, then it also outputs another state, so it outputs an h1 vector, which this thing uses, right? So the next layer uses h1 and x1 vector, and then it gives you the y1 vector and also an h2 vector, and it like this keeps happening, and eventually you just like get the final hidden state, whatever this thing is. It's going to be hn minus 1, I think. And then using this and xn minus 1, you finally get the final hidden state or something, and you also get like a y vector. So in this case the y vector would be your word. So this is like xn basically, right? So if your prediction task is to like predict what this word is going to be, then y is what you want. Essentially yn minus 1 is what you want. So yeah, this is done using an RNN. Like okay, this is a very abstract sort of a diagram. Let me draw one layer of the RNN, and it will become much clearer. So you just have the initial state, which for now I'm just gonna call it h vector. You also have the input, which is the current word. You multiply both of these with some weights. So you multiply it by whh, and you multiply this by wxh. So you multiply these through subunit, which I'm just going to call @, which is standing for matrix multiplication, right? And then you add the resultants, so add that, and then you pass it through a sigmoid function, which I'm going to denote by s, and at that point what you'll get is basically the h vector, like the next hidden state, right? So the next h vector, which I'm just going to call h dash. So this is h dash vector, but that's not it. What you can do is like pass it or multiply it with another weight, which I'll just call wyh, right? And then pass it through another activation function, which once again I'll denote by s, but it's not necessarily a sigmoid function. This one was a sigmoid function or a ReLU function based on what you're trying to do, but this could be anything. Like this could be a softmax, this could be a sigmoid, whatever you want. And then similarly, like you would have a corresponding loss, and what you get at this point is the y vector basically. So this is the output, right? Yeah, so I don't know, let's just say that you had a program which basically does a task like this. You're given you're given a sentence, and you're given an initial state which represents the sentiment of the sentence, right? And what your machine wants to do is convert that sentence, which might not like really in a literal way reflect the sentiment, like you know um, so when someone says like good for you, if they mean it in a good way, then that should translate to that I am happy that something happened for you. um, and if it's a bad sentiment, like they're saying it sarcastically or something, then it should translate to something negative, right? So maybe your H0 represents the initial sentiment, and so with every word you kind of get some sort of a hidden state, which represents once again a sentiment. And yeah, so the y values would then be words, which are like translations of the actual sentence. So you had this initial sentence, and now you got the real meaning of the sentence. So this could be used for, say, machine translation, which basically like translates between languages or stuff. um, and every layer is basically just this thing. And so from here you like get two values that you like want to use in the next step, which is the next hidden state, and the y vector, which represents the output or a part of the output. And so once again, these are just vectors which represent the words, right? So essentially you would have a sentence which you have translated to vectors using word2vec or whatever thing you are using. And what you want to do is create another set of words or vectors, which which represent another sentence sort of. Now usually what would happen is that you just use like, so these y vectors, these would be sort of a one hot encoded representation of words. So then the loss function that you want to use is just the cross entropy function, and then these are usually like given by softmax in that case, because it's a categorical classification sort of thing at that point. So you just use a softmax function and the cross entropy, and like using the cross entropy with, so like, okay, suppose you are given something in a language A and a language B, and you know what it should be in language B, then you have to train it, right? So like I just call it hat everywhere. So these are your predicted values. Your actual values, which is like actual y naught vector, you take these two and then you sort of find the loss using the cross entropy function, and then you do it like for each of these. So this gives you a loss, this gives you a loss, and so on. And then what you do is like you combine all of these and then you add them, right? And of course you multiply by a 1 by k thing. So multiply, where you want to multiply this, and so sorry, what's it's 1 by t, right? So t is just the total number of steps that you are taking, so like layers basically. And that's how you get the final value of the loss function. So now what is the training task like really doing? What are the variables here? The only variables are these values: WHH, WYH, WXH. So this is a vanilla RNN, and by the way, these values are the same for every single layer in the neural net. So the back propagation, the way it happens is that you like take all the gradients, you sort of do an average of these gradients, and that is what you use to update these weights. And yeah, so that's basically RNN, like a vanilla RNN. So I've like abstracted all of this down to this level, where you just have the layers, the hidden state, the y vector, the actual y vector that it should have been, and then a loss. And of course I'm combining these losses like this, but I'm not drawing all of that in my Graphviz plot. Is it even called a plot? Graph. Yeah, because that's messy and like skews everything. So this thing that you see over here, this is basically my RNN, and I just made it perform some training. So I'm using the step size of 0.01. I'm descending for 100 steps, and as you can see, my neural net is basically just 3 layers, and the loss function I'm using is cross entropy. The actuation function for y is softmax, while for h it's just a sigmoid. um, h0 is the initial starting sentiment, which right now I just set it to be what do you call it, a variable. Yeah, and these weights whh, wxh, sorry, hx, and it should be whx, right? And wyh, well, these variables are what was I going to say once again? Oof, I just kind of forgot. Yeah, so these are also there, in my model, but I'm not drawing those, right? Because that would make everything a lot messier, like there would be arrows flying everywhere. So just know that these are there, and this is like a very abstracted form of the neural net. Right. So this is how I'm creating the data. It's basically just this neural net, like you just input garbage values in that, and then like don't train on anything, just expect some kind of output, and you do this for hundreds of times, and that's how you get, you know, your data. I just like got the data by essentially doing what an RNN does. And then I like, before I made the actual, like, okay, when I made the RNN, like when I initialized it, the weights and biases, all of them will be different, right? So the only task that the RNN is like doing is just adjusting its weights so that the loss becomes 0. Yes, you heard it right, 0. Not the minimum value, but 0, because it can reach 0. That's the thing. Okay, why does it like, I don't think I need the diagram anyway at this point. Okay. Sorry, I have a cold. Right. So what was I doing again? Right. So right now I'm doing it for 100 data points, training it for 100 data points. There are 3 layers. So I'm using sentences of 3 words essentially. My h is 4. Well, h is the, what do we call it, the number of columns for the hidden state, and m is the number of columns for the x vector value. So like every sentence will have words, and that every word will basically be a vector of 10 values, but I'll be adding 4 more values to get like the actual thing. So every hidden state will be a vector of 4 values. That's what I should say. So every hidden state is a vector of 4 values, every word is a vector of 10 values, and then I multiply them with like matrices. In case of the hidden state, just a 4x4 matrix, and in case of the word, a 4x10 matrix. And yes, it's slightly different than all of that, because I'll be like thinking of these as row vectors, so it might be transpose or whatever, but yeah, the idea is like you multiply them, then add the thing, then pass it through an activation function, sigmoid, and then you get the next hidden state, right? And then from that you get y and all kind of stuff, the loss. Yeah. Right. So since I'm just like generating data just the way that an RNN is supposed to generate the data, like it's supposed to compute the thing, so it's no wonder that the loss does reach 0. And as you see over here, the loss like really reached 0 sort of, because it's e negative 5, which is like 0.0001. So that's very small compared to 3.3. And if I say like run this once again, who knows, it might actually just reach 0. So now it's like e negative 11, right? So let me run it again, and it will just like keep going like that. Now it's 19. So you see it's reaching 0, right? So every time I descend by 100 steps, your loss, like, it goes down. And the reason is like it is going to eventually reach 0, because it is possible for the RNN to reach 0, since the RNN, like since the data was tailor made for the RNN, as in there exists a set of values for the weights such that the RNN produces the data exactly. Yes, exactly where the loss is 0. And yeah, this is like a very cheap example, because of course real world doesn't like give you 0 loss data sets, but yeah, all it like does is prove that my implementation is working. So whenever like I'll get a real problem which RNNs is used for, that's when I'll update this. Like I'll just tell you people that yeah, RNNs can actually solve problems and it's not all bullshit. But till then you just have to wait. Oh, and I should probably like show you the self-made library at this point. But then again, you have seen it before, right, in a video. But I made some changes to it. I made the forward propagation happen such that all the gradients are set to 0, and then whenever I start descending, I just set the last node's gradient to 1, and then I descend, and it all happens automatically. Also, I made it such that the send function and receive function are essentially the same at this point. Yeah, there's a lot of stuff that I changed actually. Yeah, right. So that's it. I'll see you guys in the next video. Bye.